Now let's talk about parametric equations. Suppose I have two functions, f of t and g of t, and they're defined on some interval I. If I set x equal to f of t and y equal to g of t, then together these are our parametric equations, and t is the parameter. Basically what I'm saying is I'm defining x and I'm defining y separately, so they're independent of each other, and dependent upon a common parameter, which is t. Now, in order to graph these, I find the x value and the y value at a collection of t's, and I plot those. Let's look at this. Suppose I have a parametric equation, x is t squared minus 4 and y is t over 2, and I'm going to define it between -2 and 3. How do I graph this? Well, in order to graph it, what I need to do is make some sort of table, like I've created here. So the first thing I'm going to do is just do all of my x values. So x is t squared minus 4. So when I put in -2, -2 squared is 4 minus 4, that's 0. When I put in -1, -1 squared minus 4 is -3. When I plug in 0, I get -4. When I plug in 1, I get 1 squared minus 4 is -3. When I plug in 2, 2 squared minus 4 is 0. And when I plug in 3, 3 squared, 9 minus 4 is 5. And now I'm going to switch pen colors, and I'm going to come up here, and I'm going to find the same thing for y. For y, it's t over 2, so it's going to be -2 over 2, or 1. -1 half, 0, 1 half, 1, and 3 halves. Now, I'm going to bring up a graph. I'm going to show you. You plot the points. So I'm going to plot the point 0, 1. That's where I start. All right, so here, I'm going to come up here. Let me go to, oh, I don't know, let's go to red. So the first point right here is 0, 1. So x is 0. And that should be a -1, shouldn't it? Okay, 0, -1. So I start there. The next point I graph is -3, -1 half. So -3, -1 half is right here. So the curve goes this way. And then I'm going to plot -4, 0. So that's right here. And then -3, -1 half. All right. And that one is indeed positive. Checking my signs here, I make mistakes all the time. And then 0, 1. So 0, 1 is right here. So you see we just keep going this way. So this is a sideways parabola. You would not consider these functions in a math class you had before this, but this is perfectly okay here in calculus. Now, what if I wanted to eliminate the parameter in there? Well, let's see. Basically, you're going to have to try and do some sort of algebra that works. Now, this is the same curve we just looked at. I don't want to solve that for t, but I can solve this one for t. T is y over 2 times y. All right. So now I'm going to take this t right here and plug it into my x function. So I'm going to have x is 2y squared minus 4. So x is 4y squared minus 4, which is indeed a parabola in x. Now suppose I want to eliminate the parameters in a situation like this, where I don't have, I can't just plug one into the other. Let me start by solving the x one for sine, and that's just x over 3. And then I'm going to solve the y one for cosine. Okay, well, at this point in time, what I really need to do is use the trig identity, cosine squared plus sine squared. Okay, once I have this, I can square these two and add them. So this becomes, let's see, cosine squared is y squared over 5 squared plus x squared over 3 squared equals 1. So this is y squared over 25 plus x squared over 9 is 1. So here I have an ellipse. Now suppose I want to find a parametric equation that represents this graph. Y is 1 minus x squared. What we usually do to start with is just say, okay, let x equal t. If I let x equal t, this becomes y is equal to 1 minus t squared. Now, this is this equation written in parametric form, as long as I take the two of these together. It's pretty much almost always that straightforward. The first step is you always just set usually x equal to t and then substitute in